Good morning, students. Today, in this session, I'm going to explain about one more classification algorithm, that is SVM. It's nothing but support vector machine. So, what is this support vector machine? Support vector machine, or simply we can call it as SVM, is a machine learning algorithm based on supervised learning that can be used for both regression and classification problems, but mainly SVM is used for classification problems. So if you take any labeled data set, we are going to train the model and we are going to, and model is going to make the prediction when we have given a new input instance, and it is going to give us, it is going to categorize it into one of the two classes. This is generally how a classification algorithm works. Similarly, support vector machine also works in the same way. And what is this support vector machine? SVM is a supervised learning method that looks at data and sorts it into one of the two categories. So this is what exactly SVM will do. It looks at data and finds the similarities and sorts it into one of the two categories. As we said, SVM is one of the most popular supervised machine learning algorithms, which is used for classification as well as regression problems. But I already told you, primarily it is used for classification problems. So, what is the logic behind this SVM algorithm? So, how an SVM algorithm will look like is something like this. So, I'll explain what is this line and what is this x-axis, y-axis. Let us discuss in detail about this and the key concepts of SVM. First, let us discuss one example, and after that, I'll explain you what are the key concepts in this SVM and what is the logic behind this support vector machine. See here, there are two data sets. A sample data set is given where we are given a set of people with a different height and weight of a particular female and the male. So these are the heights and these are the weights. Now, for this particular data set, when a new instance comes, how this SVM will algorithm will classify it into one of the category. So this is how a SVM algorithm will be. So we can see in x-axis it will be weight, in the y-axis it will be height. And suppose let's add a new data point and we have to figure out it's male or a female. Now we split our data by choosing any one of these lines. So when a new data instance come here, when a new data instance comes here, what SVM will do is it is going to draw a line. So in different ways you can draw a line. Simply draw a line. Here we have drawn two types. One way we have drawn line here, and one way we have drawn a line here. So let us say this is line 1 and line. So how SVM will choose which is the best line? But to predict this gender of a new data point, we should split the data in the best possible way. For that only we require these lines. Now, suppose I am saying, when we see these previous slides, okay, these are the two lines. I am saying this is the line which best splits the data. Then you may get it out why I am saying that this is the best split. So let us see why we say that this is the best split. So why I'm saying this one is this line has the maximum space that separates the two classes. So, and if you see, suppose the next line, see these are the two lines. Try to understand here the concept. These are the two lines. This is one line, this is other line. I am saying that line 1 is the best one which splits the data. Why? Because it is having a maximum distance between these data points. That's why I'm saying that this is the best split. So you may ask why not the other line? So see here, if you take the other line, this one, line 2, okay, for one sort of category, there is a maximum space, but one sort of this category, it is very near. That's why we can't say that that doesn't have the maximum space that separate the two classes. This is how an SVM algorithm works. Now, so we have decided that this is the line which best splits the data. Why? Because we have the maximum distance having between two different data points. And we also say that the distance between the points and the line should be as far as possible. That means the distance between the line and the points, it should be as far as possible, then it is going to give us the correct predictions. And see here, this line, this we call it as the line, and this particular distance between these two dotted lines, we call it as the distance margin. And these two, we call it as the points. Yes, even in linear regression also, we discussed that these are represented as data points. This we say regression line. But coming to here, there are some technical terms coming to support vector machine, what we call. So in technical terms, we say that this line is the hyperplane. Okay, whatever the line we draw to separate the two categories, this we call it as the hyperplane. Okay, how we say that they're the regression line. Here we say the hyperplane. And the data points which are nearer to the distance margin. The data points which are nearer to the distance margin, generally we call them as the support vectors. That's why the name algorithm, we call it as the support vector machines. The data points which are nearer to this distance margin, we call it as the support vectors. And where these support vectors are the extreme points in the data set. So these which are nearer to these support vectors, these places an important role in the SVM algorithm. And see here, we have drawn other two lines, dotted lines nearer to these support vectors. And the line to the above, generally we call it as the D plus. Okay, shortest distance to the closest positive point, we call it as D plus. And the shortest distance to the closest negative point, we call it as the D minus. So this is this line. We have drawn a hyperplane and we have drawn it two points. The distance from here to here, we call it as D plus. And the distance from here to here, we call it as the D minus. That is what we call it as the distance margin. So see here, the distance margin, the total here, this total, it is called as the distance margin. This total is called as the distance margin. So this is here. See, from the distance margin, we'll get the optimal hyperplane. Okay. Now, based on this hyperplane, okay, so we can say that the new data point, okay, belongs to the male gender. Why? Because it has been this side, where the male side. So the new data point, according to the support vector machine calculation of this distance margin and hyperplane, we conclude that this particular new data point belongs to the male gender. Now, what happens if the hyperplane is not optimal? Okay, now we are saying this is optimal hyperplane, but if the hyperplane is not optimal, suppose if we select a hyperplane having low margin, okay, see, suppose here we have selected the second line from earlier thing. So there is less distance D minus, okay, maximum distance is there. So we say that this is not a hyperplane. Why? Because there is a low margin. Then what is the problem here is, there is a chance of misclassification. You see here, if we would have selected this hyperplane, this particular data point, it would have misclassified and it would have given as a female gender. But actually what it is male gender. So we should be taken care while we are selecting the hyperplane. Why? Because if you doesn't select hyperplane as an optimal hyperplane, what is the disadvantages? There is chances of misclassification. Now, one more thing. Suppose we have a sample data set like this. Okay. When we have a sample data set, how SVM will sort it into two categories. So here in this case, if this is one dimensional, we cannot use a hyperplane. Then what we are going to do? How SVM will work in this case? So what it will do is, SVM have a technique called as kernel. Okay, it uses a concept of kernel, which will take the one-dimensional input and transfer it into a two-dimensional output. That is with the help of a kernel. Okay, see here then. So once this particular one-dimensional is converted into two-dimensional plane, and it is going to divide the data into 2 square, and that is given by as y equal to x square. This hyperplane, this transformation is given by y equal to x square. Now, suppose there is a data set something like this. How to perform SVM for this type of data set? When you have a nonlinear data, and you want to perform SVM on this data set. So how it is going to work? See, this is a sample data set. First of all, we are going to segregate the two classes. So when we segregate and when we have drawn an hyperplane, we can say that by seeing that this, it is not a optimal hyperplane. Then what to do? Then how SVM works? So again, we introduce a concept of kernel, and this is two-dimensional data. It is going to transform into three-dimensional data. This is the three-dimensional data where this is called as a hyperplane. It divides the or sorts it into two different categories. Okay. There are two types of SVM, that is linear SVM and non-linear SVM. So what is linear SVM? It is used when data set can be classified it into two classes using a straight line. So this you can say that it is a linear SVM. And coming to the non-linear SVM is used when the data set cannot be classified it into two classes using a straight line. Yes, when we have a data set this, drawing a optimal hyperplane anyway, you can't classify it into two classes. That is called as the non-linear SVM. So when that particular thing comes into pictures, what we will do, we are going to introduce one concept called as the kernel function. So what is this kernel functions? Kernel functions takes low dimensional input space and transform it into a high dimensional space. That is, it converts non-separable problem into a separable problem. Suppose this is the low dimensional space. When we make use of a kernel function, so it is going to be divided it into separable problem. Now this hyperplane is used to make it as a separable problem. So this will become a high dimensional space. Okay. So here in this one, we say that this is a hyperplane, and the points touching this hyperplane generally we call it as the support vectors. So this is what the same thing, linear SVM is used for linearly separable data. That is, if the data set can be classified into two classes by using a single straight line, then that we call it as a linear. And we data set cannot be classified by using a single straight line, then such data is termed as a non-linear data. And you can give as example something like this is linear and this is non-linear. Coming to what are the basic steps in SVM? By the earlier example, maybe you have come to know that what are the basic steps in SVM is. We are going to select two hyperplanes, okay, which separates the data with no points between them. So these are the two lines with an optimal hyperplane where there is no data points in between these. And maximize, we have to distance, that is the margin. This is the maximum margin. And the average line will be the decision boundary. So this is the decision boundary, and this itself we call it as the hyperplane. So see here, data is linearly separable. How this working? Let's consider two classes, apples and lemons. Okay. SVM will search for apples that are very similar to lemons, which are yellow and have elliptic form. So this will be a support vector. These two will be the support vector. The other support vector will be a lemon similar to an apple, green and round. So other algorithms, what it does is it learns the differences, but while the SVM will try to learn the similarities. Okay. The same thing if you visualize this example in two-dimensional. Okay. How it will be is it will be something like this. See here. Okay. So finding. So here the best line is the line that is far away from both the apple and lemon examples will be the largest margin. So this will be the, okay, we are going to take one hyperplane that will have the maximized margin in both ways. So the support vectors are the data points that defines the position and margin of the hyperplane. So in this way, if we draw the line, we have a maximum space. So it is going to classify the classes into two different categories. So when data is not linearly separable, okay, we already discussed one. So we will use the kernel trick. This is very important point. And the basic idea is when a data set is inseparable in the current dimensionals, add another dimension. That's it. If it is one dimensional, make it into two dimensional. When there is a problem with the two dimensional non-linear, just convert it into three dimensional. So see here, it is a two dimensional. Just we have added one more dimension and we have the space has increased. So we will get an optimal hyperplane. This is how SVM works with the two-dimensional non-separable space. And kernel is used due to set of mathematical functions in support vector machine and provides the window. This provides the window to manipulate the data. It converts low dimensional space into high dimensional it separates a non-linear data, and we are going to add another dimension, just we call it as an x3. And this transformation, how it is going to done is, the formula is simply we are going to use the x1 plus x1 whole square plus x2 whole square. And these transformations, generally we call it as the kernels. So here you may get how many types of kernels we can use in SVM. There are many types of kernels are there. In this, when while we are implementing SVM algorithm, you can make use of any of these kernels. That is, one is polynomial kernel, Gaussian kernel, and in our program, we are going to use this radial basis function, RBF, okay, Laplace, sigmoid, and ANOVA RBF kernel. Okay, in this radial basis, RBF kernel is the most important and popular kernel that SVM is going to use. The same example. So this is the linear one-dimensional, and after, with the help of kernel function, when you convert it into two-dimensional, it will convert it into something like this. Okay, and if it is a two-dimensional data, where it is a non-linear, we are going to convert it into 3D. Okay, adding one more line between level 1 and level 2, then we can easily separate the data into two categories. Okay. So what are the pros and cons of SVM? SVM classifiers, of course, offers great accuracy and work well with the high dimensional space. Why? Because the help of kernel. And basically uses a subset of training points, and it results uses very less memory. Why? Because subset of training points as we are using. But coming to some of the limitations, but in coming to the real-time applications, when we have a large data set, high dimensional space is different and large data sets is different. It is going to have a high training time. So hence in practice for real-time application may be not suitable for large data sets. And another disadvantage is do not work well with the overlapping classes. Okay, when we have an overlapping of two different classes, maybe sometimes SVM doesn't give us the accurate results. This is one of the disadvantage of this SVM. Thank you.